So the grassification project aims at the valorization of roadside grass cuttings into higher-end products like biomaterials. This means that you need to develop new processes, but it also means that you need to gather the right amount of grass at the right location, at the right time, the right quality, and all of this preferentially at the lowest cost. And this calls for a good mobilization strategy of these grass cuttings. A good mobilization strategy takes into account all activities and processes, including transport and logistics of all steps alongside the supply chain. This means from harvesting at the roadside up to storage and stabilization and transport towards the end producers who turn the products into biomaterials. To address the mobilization of grass clippings, we used our in-house developed service called MOOC. It's a supply chain optimization service. Together with the partners, we calculated all roadside versions and mapped them, including all sites and installations active, like storage, like end processing. And from there, we turned this into an optimal supply chain network. So we also took into account different roadside types, like highways, municipal roads, and regional roads, and also included important physical parameters, such as the contamination, which is very important for cuttings of grass, like sand and plastics. We also included different harvest methodologies, like cutting grass and flailing grass, who also have an impact on the end result, the quality of the grass. With all these conditions and criteria correctly defined, we used our MOOC model to calculate how all this grass from the roadsides could be delivered to the end processes in the optimal way. This provides a grassification project with all kinds of useful information, like the mobilization cost, the number of vehicle movements, and the transport distance to mobilize the grass. With our MOOC model, we could also address differences in regional strategies. In Flanders, for example, roadsides are cut and collected by default, while in the Netherlands and the UK, it's another strategy where they cut the grass, but oftenly leave the grass at the roadsides. With the MOOC model, we could also conclude that in the regions, the grass availability is high enough to foresee current practices like composting, but also incorporate future technologies like fibers incorporated in biomaterials. As one of the results for Flanders, we could conclude that a mobilization cost about 55 euros per ton seems reasonable, but also that if you choose your end processing location smartly, you could reduce these costs to 40 euros per ton. This cost information we provided to our Vito colleagues, who do a technoeconomic assessment to see to which extent these new technologies are economically feasible.
The mobilization cost is an important input to the technoeconomic assessment. One of the main goals of grassification project is to assess the viability of producing biocomposite material from the grass fibers. The biocomposite materials are receiving increased attention due to their low cost and low environmental impact. Consumer awareness is also increasing due to the government policies and also due to the social influence. Generally, the mowed grass is sent to composting sites. However, if this grass can be directed towards the industries which produces biocomposite material, then this can have a potential to replace the plastic industry. The mowed grass can be made into fibers, which are used to produce various products in different manufacturing processes such as extrusion, injection molding, thermoforming. The fibers can also be directly used in manufacturing processes such as pressing to make construction materials, panels, insulation boards, and also in needle punch processes to produce geotextiles. The fiber production process involves steps such as mowing, cutting, chopping, screw pressing, and drying. At the end of these processes, we get the fibers. The fibers are a very important input to the final various products envisioned in the grassification project. So the mass and energy balances of these processes and also the economic data of these processes is used in a technoeconomic model, and the results of our technoeconomic assessment shows that the fiber final production cost is competitive with the other natural fibers available in the market. The technoeconomic assessment is an important tool to assess the economic viability of a technology. Our results shows that the production of grass fibers has a lot of potential and it is promising a natural fiber in the future.